We good?
We're good.
Okay, so pretty much Louisiana's wetlands are really screwed up. For the last almost century, there have been massive wetland losses throughout Louisiana, mainly due to constraining the Mississippi River as part of trying to expand human populations. To this end, many creation and restoration attempts have been made. This, my part of this will focus on finding the best between two different restoration methods, those being sediment transfer and river diversions. Since 1950, Louisiana has lost about 4,000 square kilometers of wetland space. And something to keep in mind is that Louisiana itself is 52,000 square kilometers. So picture that square of wetlands lost, and that's not even comparing it just to the wetlands itself. Surely there's very little natural wetlands left. It's roughly 13% of the state just in wetlands loss. But most of this is due to damming up the Mississippi River, which prevents sediment transfer down the stream, as well as water transfer for needing to rehydrate anything. And nutria were introduced as a way to get raccoon skins whenever they ran out of raccoons, and they ate literally everything in wetlands. There have been several studies done, most predominantly Louisiana Coastal Study, which has been completed, but there's still trying to quantify all the data, and Coast 2050, which is just pretty much looking at what we're doing now and figuring out a way to get it back. Okay, sediment transfer can be as simple as undamming portions of the Mississippi River. However, it is most predominantly bringing in sediment from other areas by the truckloads, just tons and tons of debris and sediment, and dumping it into what has become a deep water habitat. This will allow that area to become an emergent habitat yet again, and support life that pretty much cannot grow because the water was deeper than the 6.5 feet that requires it to be a wetland. This is a lot of work to be done at once, but that's just it. You do it once and it's done in theory. There is some erosion that happens of this. In the LaBranche Bayou, there has been about a 10 to 15% degrade in the amount of land that it produced in the few years after it was finished. And just for clarity's sake, here's the LaBranche Bayou. You can see it's right outside New Orleans. It was pretty much destroyed whenever they built I-10. But after many years of it not being there, they were able to build it back up by transporting tons and tons of sediment and dumping it in there and creating emergent wetland. Now, river diversions are similar to sediment transfer in the fact that they're just offshoots made out of the river using levees that have dam controls. They can spread sediment into an area in small quantities, but they can also bring in water, which can serve multiple purposes as well, such as controlling the saline content of the wetlands that are immediately around it, or like I said earlier, bringing it more sediment. Now, these levees cost a lot to produce, but yet again, they are a one-time fix, and you can serve many more square footage of wetlands with just this one levee that you build with dams in it to control floodwaters. So in the long run, you can restore a lot more land with these than something like a sediment transfer. This is an example picture of a diversion dam. Obviously, this isn't anything like what you would actually find on the Mississippi. You'd find smaller, more spread out versions of this, but this is the best that I can find. And there's really no way to compare these based on costs. No one has literature based on how much they cost to do it compared to how well it works. So I had to figure out a new way to do this. And I also couldn't do anything on crevasses because the information is just so contradictory of whether they work, whether they don't work, how long they work, how long they don't work. So the final result was sediment transfer versus river diversion, and river diversion won.
My study focused on macroinvertebrate communities in the created and historic wetlands, comparing them in an effort to know the effect of different methods of wetland creation by looking at macroinvertebrate communities and to use that information to gauge which methods we should use in the future and what methods we should use to offset natural disasters like hurricanes or oil spills. We chose macroinvertebrates because, as we talked about in class, macroinvertebrates are often used to create like biodiversity indexes. My hypothesis and research question. The research question was what methods were most effective at creating healthy macroinvertebrate communities within the created wetlands when compared to historic wetlands, and also when compared to deep water habitats that were created after the wetlands were destroyed. The independent variable is the method of creation, water redirection, use of dredge materials to dump them in, and marsh terracing. Dependent variables will be the means by which we compare macroinvertebrate communities like species richness, species diversity, and population density. The method I used was creation of a matrix, which is basically just a giant table that has a whole bunch of sources, the methods they used, and the dependent variables we mentioned earlier. I divided this matrix into 3 sections, one regarding natural and anthropologic events like hurricanes, oil spills, draining, another one which showed wetland creation from places other than the Gulf Coast that could possibly be brought into the Gulf Coast area, and finally wetlands in the Gulf Coast and how they have been responding. These sections will be compared at the end during the analysis to determine which ones could be used together or which ones would be best used in which situation. This is one of the matrices. This is the natural and anthropologic effects. I tried to make the graph and stuff as big as I could and still fit on the slide. As you can see, it shows the event description, species richness, species diversity, population density, and the effect on abundance, as well as some notes so that specific things about each study could be used. This is the one that's non-Gulf Coast wetlands, and then the next 2 are from Gulf Coast wetlands. The analysis, when compared to historic wetlands in extended time cases, none of the created wetlands of any method were ever equal with macroinvertebrate community health. There's just 2 examples. Every single one of them was the same though. Also, attempts to return water to previous wetlands showed very slow results, often taking from 7, I think was the shortest amount of time, up to like one was at 20 years, and they still had not even reached remotely close to the previous macroinvertebrate community health. Additionally, some things that I noted were that oyster populations were in every case compared or correlated to increases in health in macroinvertebrate populations. This was in multiple studies as well. And the most effective use was actually putting down coconut fiber mats in other situations. These were slightly ahead of marsh terracing and using dredge materials to create wetlands. Drawbacks to the study. The biggest drawback was the focus on macroinvertebrates. If I were to do the study again, I would focus on biota as a whole to determine the health of the wetland, because the number of resources was just too small to create a large enough matrix to receive significant results. In the future, I would also suggest a study in which oyster populations are introduced to similar created wetlands to determine if the oyster population does in fact cause an increase in wetland health. And additionally, a lot of studies noted the salinity of the wetlands, but none of them actually focused on this area, and I think a study focusing on the salinity of the wetland compared to macroinvertebrate health would also be helpful. For this study, the main macroinvertebrates focused on were nectin, which are shrimp and other similar macroinvertebrates, oysters, and in some cases mayflies and stoneflies.
Okay, Jay and I were kind of working on 2 different aspects of potential correlations between loss of wetlands, and Jay was doing average income and I was doing population density. So using population census data that was available on Louisiana.gov's website, I broke up the data by parish, looking back from 1960 to 2010. The first couple slides here are going to be density by decade, starting with 1970 and then in 1980. If you're looking at it by decade, there's a natural progression just in growth of pretty much all of the parishes. It really gets interesting when you start looking at the loss gain maps. This one breaking down the change in 1960 to 1980. The areas on the map of dark red will indicate the areas of greatest loss, and the areas of dark blue will indicate the areas of greatest gain. The only parish that's dark red is Orleans, and throughout each of the maps, it was the area with the greatest amount of loss. So from 1960 to 1980, this is important because 1970 was estimated to be the decade of the greatest rate of loss of the wetlands. And this one going from 1990 to 2010, you can see Orleans is still the area of greatest loss. The areas in the southeastern peninsula of Louisiana are also in the red, and then there's areas inland of dark blue, the most gain. And then this is a breakdown from 1970 to 2010. There's one problem with the data from 2010, or in between 2000 and 2010, would be Hurricane Katrina. That really skewed a lot of the data just because of displacement because of the storm. Jay and I will allude to this in a little bit. We had issues trying to find data on wetland loss. We had plenty of studies that indicated maps for wetland loss. A USGS study of land loss from 1932 to 2010, I believe, is what it was. Unfortunately, we couldn't get the data for access on GIS purposes, so we couldn't really show exactly what we wanted to. So that was just some of the difficulties, and then jail to income.
So what Zach said, I did income along with his population, and what I did was I went on the same site he did, Louisiana.com for census. I would have to go through the individual parishes and find like median household income. That way I could put into Excel and make we use it to make data to input onto the GIS system. And I only could use the 2010 and 2000 because me and Zach could not find any previous years for median household income. I don't know why that would be, but
Yeah, I think they changed which, like the number of folks that got the long survey about income.
yeah, because in the earlier
2000 was the first year that they started.
in the earlier censuses they would have like categories like your race and it's just basically the population.
They had jobs too, I
And
think.
jobs,
It just
yeah.
didn't have income.
They just didn't have income, so my data was kind of narrowed. So I used this to make maps, and the first map here is 2000, and you can tell that. And let's keep in mind that from 2000 to 2010 there was inflation. So the way I use the data, I in GIS you can select different ways to quantify your data, and I chose the one that would equal amount. So you can tell in 2000 compared to 2010, the income actually rose a little bit, and especially in Cameron County or Cameron Parish, which the population in that one's only like 6,000.
Yeah.
The
And that's the one to the far left.
far left
on the coast.
like a really blue one. That surprisingly they all increased a little bit. And this is the shapefile we were talking about. This is the Louisiana wetlands that we tried to break down. You can't really see it here, but this file I put on here, that it shows, it actually has the acreages for each type of wetland, but we couldn't place it into the individual parishes that we were monitoring. And this file actually has over what, 2 million,
Yeah.
2 million.
I'd say it was an extremely large file. It just, we couldn't, we broke it down by parishes. Ideally, we would have done tracks because it's much smaller. Unfortunately, we couldn't utilize that with the wetlands loss data. But in an ideal world, we would have taken the wetlands loss and then gone by decade and show how the changes.
This file actually
Yeah.
breaks it down in individual types of wetlands, and we were trying to break it down to like the coastal wetlands and crop it into the parishes that we use, but we were unable to do that. So it kind of skewed our
And just
results.
back to this, I mean, you can look at these maps and say that there's a shift inward just in the gains, but without us being able to show like the data that we wanted to, you can't definitively say that the loss of the wetlands is correlated to the shift inward.
Can you clarify what you mean by a shift inward?
So like the populations from the coastal regions shifting inland as the wetlands degrade. So if you look back,
So let's categorize these as two different sets of parishes. Coastal parishes
coastal and inland.
and non-coastal parishes. What's happening in the coastal parishes and what is happening in the non-coastal parishes over time?
The coastal parishes initially start with more. If you look here at the lower right, the peninsula, the lower right parish, 1970 and then to 2010, it actually decreases. See, it goes from the light blue to the dark blue. So those would be the areas of the greatest wetlands loss, that peninsula, that entire southeastern, actually over just prior to Cameron. So that's our hypothesis was that as the wetlands would degrade, the population would shift inland to the more northern parishes as a result of job loss.
And which map shows that? Change, right.
This would 1970 to 2010.
We have to keep in mind that these people were living off, like a lot of them use wetlands for jobs. So as the wetlands become destroyed or higher salinity, a lot of their.
So you saw, as people moved inland, the amount of income made on coastal wetlands.
Raised or came higher though. I mean, I don't know why, but maybe it's because there was less people, or
What do you need as a control group to compare the change in income in your coastal parishes to? What should you use as a control group?
Maybe average income of the whole
the
country, or just
the whole state.
yeah, or the
Right,
country in
look
general.
at, so a good control would be looking, and a good comparison would be the change in median income between the coastal areas and the non-coastal parishes, which you could have overlaid with Zach's data on change in population also. So that's the part that was kind of missing from the economic data. You have the comparison of coastal and non-coastal parishes for population, and you can now track what's happening with population, but you can't really track relatively what's happening with coastal parishes as far as their median income, because in general, as time passes, average incomes, because of inflation, always just end up increasing also. So with that, if you have that second piece of information, then you can see if the people follow and the money, the incomes change in a similar way also. And then, so since you don't have wetland loss data, you would then imply that, oh, it's because we're losing
That would be a
wetland acre.
hypothesis though, right? Like you would have to.
And, right, and then, if you really wanted to see how how wetland loss influenced population and changes in income, you would, like you said, you'd have to find a way of tagging each parish with with an amount of wetland that was lost. And statistically, if you can't overlay those two data sets perfectly, that's okay, because then you could go with a simple ranking. This coastal parish had the most loss.
Yeah.
This had the second most loss. And then you could do a correlation. Then you could do a correlation on that.
Yeah.
It would-
You would have to have data from before and then after, or like to show your
Well,
loss,
you
right?
would, so that final shapefile that you showed, that is, that you didn't overlay, there, that one right there.
Yeah.
That tells you how much area was lost in each one of those blocks. Or not each one of those blocks, but in a given area.
Yes.
So you could have displayed that on a map, and then you could have come up with a rating, some kind of rating system for each parish based on that. You didn't necessarily have to, you could also intersect them also. That's another thing you could do. You could do an intersected GIS and literally code those sections with which parish they're associated with, some kind of overlay analysis.